Thank you for visiting my YouTube channel. I know you want to watch the video. Before I get into the content, I'm going to talk about my nonprofit, the Accelerated Training Program, a cybersecurity and digital literacy nonprofit based in Charlotte, North Carolina. We are looking to provide accessible cybersecurity education and digital literacy skills to underrepresented groups from the K through 12 space right now, but we have on our roadmap collegiate, elderly populations, etc. Pretty much anyone from an underrepresented group. We want them to get cybersecurity education and digital literacy skills to bring them into the ever increasing digital world that we live in now. If that sounds like something that you're interested in, we do have a donate button if you would like to donate monetarily. We're always accepting donations. If you would like to volunteer your time, we have a volunteer tab where we're looking for workshop volunteers. Currently, we have 1 month workshops, but we're looking to expand that in 2024. Board members, advisory board members, and a grant writer. So if you're a grant writer, if you have experience in grant writing and also winning grants, we would definitely love to have you on our team. To be considered, please complete the volunteer form here, which is a link that will navigate you to a Google form. And again, we're a cybersecurity, digital literacy nonprofit, and we would love to work with you if that is your passion as well. Thank you. Have a good day. And now the video is going to start. Hello, and welcome to another video for the Advent of Cyber 2023 rooms. Again, I'm doing these rooms out of order, but I am committed to completing all of the rooms by Christmas or by the 27th, which is the deadline. So today's video is day 9. It's malware analysis. She sells C# shells by the C2shore. Say that 3 times fast. Okay, so let's start the room. Let's go. Let's do this. Okay. We're not going to look at the walkthrough. Having retrieved the deleted version of the malware that allows Tracy McGreedy to control Els remotely, Forensic McBlue and his team has started investigating to stop the mind control incident. They are now planning to take revenge by analyzing the C2's back-end infrastructure based on the malware source code. So the learning objectives. In this task, we will focus on the following vital learnings to assist Forensic McBlue in analyzing the retrieved malware sample. The foundations of analyzing malware samples safely, because that's important. The fundamentals of .NET binaries. The DNSpy tool for decompiling malware samples written in .NET. Building an essential methodology for analyzing malware source code. Malware handling 101. Warning. Handling a malware sample is dangerous. Always take precautions during your analysis. As mentioned, handling malware is dangerous because it is software explicitly designed to cause harm, steal information, or compromise the security and functionality of computer systems. Given this, we will again introduce the concept of malware sandboxing. A sandbox is like a pretend computer setup that acts like a real one. It's a safe place for experts to test malware and see how it behaves without any danger. Having a sandbox environment is essential when conducting malware analysis because it stops experts from running malware on their actual work computers, which could be risky and harmful. A typical environment setup of a malware sandbox contains the following. Network controls. Sandboxes often have network controls to limit and monitor the network traffic the malware generates. This also prevents the propagation of malware and other assets. Virtualization. Many sandboxes use technologies like VMware, VirtualBox, or Hyper-V to run the malware in a controlled, isolated environment. This allows for easy snapshots, resets, and disposal after the analysis. Monitoring and logging. Sandboxes record detailed logs of the malware's activities, including system interactions, network traffic, and file modifications. These logs are invaluable for analyzing and understanding the malware's behavior. So, connected to the machine, we're going to need the VM, it's split screen, and we're using the RDP because we have a Windows machine. Okay, so this is our username, our password, and our IP address. Okay, optional. Building from the VM on day 8, you could use the password to unlock the zip archive Juicy Tomatoy and access the malware sample for today's decompilation exercise. However, for your convenience, the VM on this task will have the defango malware sample placed in the artifacts folder on the desktop. Okay, so check the intro to malware analysis room as a refresher for static analysis concepts. Okay, introduction to .NET compiled binaries. .NET binaries are compiled files containing code written in languages compatible with the .NET framework, such as C Sharp, VB.NET, F Sharp, or Managed C++. These binaries are executable files with the .exe extension or dynamic link libraries, DLLs, with the .dll extension. They can also be assemblies that contain multiple types and resources. Compared to other programming languages like C or C++, languages that use .NET, such as C Sharp, don't directly translate the code into machine code after compilation. Instead, they use an intermediate language, like a pseudocode, and translate it into native machine code during runtime via a common language runtime environment. This may be a bit overwhelming. In simple terms, it's only possible to analyze a C or C++ compiled binary by reading its assembly instructions, its low level instructions. Meanwhile, a C sharp binary can be decompiled and the source code retrieved since the intermediate language contains metadata that can be reconverted to its source code form. Okay. Basic C sharp programming. Based on the elves' initial checks, it has been discovered that the retrieved malware is written in C sharp. So let's quickly discuss C sharp's code syntax to analyze the sample effectively. You could skip this section if you're already familiar with C sharp. Otherwise, click the view code snippets below. So we're going to do it. Okay. Names, classes, functions, and variables. For this section, let's use this code snippet here. Okay. So, a namespace, a container that organizes related code elements such as classes into a logical grouping. It helps prevent naming conflicts and provides structure to the code. In this example, the namespace demo only is the namespace that contains the basic programming class. Class defines the structure of behavior through functions or methods of the object it contains. In this example, basic programming is a class that includes the main function and the show output function. Moreover, the main function is the program's entry point where the program starts its execution. Here's our class. It's an internal class, beginning programming. So this is the main function. This is the entry point, and then we have a show output function. Okay. A function, a reusable block of code that performs a specific task or action. In this example, the show output function takes a string through the text argument as an input and uses it on console.write line to print it as its output. Note that the show output function only receives one argument based on how it is written. And we're looking for a string. Variable, a name storage location that can hold data such as numbers, integers, text, strings, or objects. In this example, toPrint is a variable that handles the text hello world. To print hello world. And we call the show output function and we pass in toPrint, which is going to pass in hello world. Going to show output, it's going to write the text, and the text is hello world. So it's going to print hello world. For loops. A for loop is a controlled structure used to repeatedly execute a block of code a specific number of times. It typically consists of three main components: initialization, condition, and iteration. Let's use the example below. So we initialize this to 1. So while I is less than or equal to 5, it's going to write I love McSkitty, and then it's going to increment by 1. In this example, the loop is initialized with 1 and stored in the variable I. Checks if the variable is less than or equal to 5 and increments 1 to itself after each iteration. So in simple terms, the code snippet means that it will call the console write function 5 times, since the loop will count from 1 to 5. Loops can be immediately terminated using the break. Okay, conditional statements. Conditional statements like if and else are control flow statements used for conditional code execution. They allow you to control which code block should be executed based on a specific condition. So, if the number is greater than 5, it's going to write the number is greater than 5, otherwise, the number is less than 5. Based on the example above, the if statement checks whether the number variable contains a number greater than 5 and prints the string. The number is greater than 5. If that condition is not satisfied, it will go to the else statement, which prints the number is less than or equal to 5. Essentially, it will go to the code block of the if statement if the number variable is 7, and it will go to the else code block if the number variable is set to 4. Okay, import modules. C# uses the using directive to include namespaces and access classes and functions from external library. So it's using the system namespace. The code snippet above loads an external namespace called system. This means that this code can now use everything inside the system namespace. Don't worry if you find these code snippets a little overwhelming. Once we start analyzing the malware, the following sections will be much easier to understand. Okay. The code snippet above loads an external namespace called system. This means that this code can now use everything inside the system namespace. Don't worry if you find these code snippets a little overwhelming. Once we start analyzing the malware, the following sections will be much easier to understand. Okay, C2 primer. According to Forensic McBlue, the retrieved malware sample is presumed to be related to the organization's remote mind control over C2 incident. So, to build the right mindset in solving this case, let's look at the run through below about malware with C2 capabilities. C2, or command and control, refers to a centralized system or infrastructure that malicious actors use to remotely manage and control compromised devices or systems. It serves as a channel through which attackers issue commands to compromised entities, enabling them to carry out various activities such as data theft, surveillance, or further malware propagation. Okay, so user executes the malware. Malware connects to the C2 server and asks for instructions. C2 server responds with sets of instructions. So then the victim executes the malware instructions retrieved from the C2 server. Malware reports back the output. Attacker connects to the C2 server and issues commands to be executed on the victim's machine. Seeing C2 traffic means that malware has already been executed inside the victim machine, as detailed in the diagram above. In terms of cyber kill chain stages, the attacker has successfully crafted and delivered the malware to the target and potentially moves laterally inside the network to achieve its objectives. To expound further, malware with command and control capabilities typically exhibits the following behaviors. HTTP requests. C2 servers often communicate with compromised assets using HTTPS requests. These requests can be used to send commands or retrieve data. Command execution. This behavior is the most common, allowing attackers to execute operating system commands inside the machine. Sleep or delay. To evade detection and maintain stealth, threat actors typically instruct the running malware to enter a sleep or delay for a specific period. During this time, the malware won't do anything. It will only connect back to the C2 server once the timer completes. Okay, we will try to find these functionalities in the following section. So now we're going to decompile malware samples with dnspy. Now that we've tackled the theoretical concepts to build our technical skills, let's start playing with fire, or let's start playing with malware. Since we already assumed that the malware sample is written in C Sharp, we will use dnspy to decompile the binary and review its source code. dnspy is an open source .NET assembly, C Sharp debugger, and editor. It is typically used for reverse engineering .NET applications and analyzing their code, and is primarily designed for examining and modifying .NET assemblies in a user-friendly, interactive way. It's also capable of modifying the retrieved source code, editing, setting breakpoints, or running through the code one step at a time, such as debugging, called debugging. Note, as mentioned above, we won't execute the malware. So the debugging feature will not be discussed in the following sections. To proceed, let's go to the virtual machine and start dnspy. Okay, so we double clicked. Once the tool is open, we will load the malware sample by navigating to File Open and okay, so File Open, and we're going to go Desktop, Artifacts. Okay, saying nothing is there. Okay, all files. Okay. Now we have the juicy tomatoid deframed. Okay, once the malware sample is loaded, you have a view like the image below. The next step is to click the main string, which will take you to the entry point of the application. Okay. Okay. As discussed in the previous section, the main function in a class is the program's entry point. This means that once the application is executed, the lines of code inside that function will be run one step at a time until the end of the code block. However, we won't be dealing with this function yet, since reviewing it without understanding the other functions embedded in the malware sample can be a bit confusing. Okay, so we're going to understand the malware functionalities. You might have been a little overwhelmed when you saw the main function, but don't worry, we'll discuss the other functions before building the malware execution pipeline. Focusing on the individual functions before dealing with the main function can be considered a modular approach. Doing this allows us to easily break down the malware's functionalities without getting bogged down with long code snippets. Moreover, it allows us to recognize some potential execution patterns that ease our overall understanding of the malware. To start with, view the list of functions inside the program. Oh, where is it? Okay, program. Class by clicking the highlighted section as shown below. After clicking, you will see the functions in the drop-down menu. Let's run through them individually to better understand each code's meaning. You can click on the items as we discuss them to compare the code in dnspy. It's also advisable to review the .NET Framework documentation to learn more about the internal functions mentioned in the following sections. Get it. Okay. Based on the source code, the GetIt functions use the web request class from the system.net namespace and is initialized by the function's URL argument. The name is already a giveaway that the web request is being used to initiate an HTTP request to a remote URL. And this is the user agent. I think this is one of the questions we're going to see. Copy. Yep. Okay. I like answering questions when I see them. Okay. Note, you can render the namespace details by hovering over the web quest string, similar to what you see in the image above. By default, the HTTP method set to the web request class is get. This means we can assume that the HTTP request made by this function is a GET request. The 3 lines of code inside the function can be expanded by the comments written for each line. In other words, the GET function accepts a URL as its argument, configures the parameters needed for the HTTP GET request, custom user agent, and then returns the response, the value of the response. Post it. So that's here. Like the getIt function, the posted function also uses the web request. However, you might observe that it has configured more properties than the first one. The most notable is the method property, wherein the value is set to post. So that's here. This means that the HTTP request made by this function is a post request, and it submits the second argument as its post data. Okay. The notable lines are annotated with comments on the code snippet below. So, okay. So, accepts 2 arguments. So here is post. Okay. What is the key? What key is used by the malware to encrypt or decrypt? So I'm going to go to encrypt. Okay. What is the first HTTP URL used by the malware? Mm, okay. I'm going to see if I could do this on my own. Okay, so HTTP McGreedy secret c2.thm reg. Okay. So and I just used it here. Um okay, this is 15,000. I want to say 15. Okay, I just guessed that. So, what I did, I looked at this 15,000. I just assumed it was in milliseconds. A millisecond is one thousandth of a second. So, doing 15,000 divided by 1,000. So, doing 15,000 divided by 1,000 is 15. What is the C2 command the attacker uses to execute commands via command line? So, did I not execute command? Process. Start. Start. No. Okay, so that's not it. Uh-uh. Implant. So this is the program. That's a decryptor. Execute command. Wait, where is main? Okay, main is here. This is what I'm looking for. Okay. Okay, so this is stashmcgreedy.thm. Okay. What is the C2 command the attacker uses to execute commands? Okay. It's not parse. Okay. I don't think it's get it. No, because that is this here. So, okay. So I was able to answer the majority of them. Let's go. Okay. Where are we? Okay, so that's the post. So converts the data into bytes. We're passing in a URL in the data. Okay. We're doing a post. Excuse me. User agent has been redacted, preparing the data to be sent, return the response of the post. In simple terms, the posted function accepts an additional argument as its post data, which is then submitted to the target URL and returns the response it receives. The sleeper function only contains a single line, a call to the thread.sleep function. The thread.sleep function accepts an integer as its argument and makes the program pause for milliseconds. Okay, so I was right, based on the value passed to it. So yeah, so it's based in milliseconds. The usage of the thread sleep function is typically behavior malware uses to pause its execution to evade detection. Execute command. Given the namespace and class name, system.diagnose.process of the initialized process class, first code line, assumes this function is being used to spawn a process. According to its Microsoft documentation from the initialization of the process start info properties, we can also see that the file to be executed is command.exe and that the execute command's argument command variable is being passed as a process argument. In short, the code snippet results to command.exe slash C and then the command. Okay. So we still got some time. Okay. Prepares the command to be executed via command. Start the process to trigger the OS command. Returns the output. So I said that. I said start. Okay. What command does it use to execute? Is there a shell? Okay. Excuse me. Excuse me. Another thing to note is that the Windows style property is set to process Windows style.hidden. This means that the process will run without a window. As such, it's a way to hide the malware's malicious command execution. This function serves as the malware's OS command execution function. Encryptor. No, we won't be diving deeply into cryptography, so we will skip discussing the important functions used to encrypt. The giveaways in this function are the AES classes used in the middle of the code block. If you hover over the initialization of the AES manage variable, it also shows the namespace system security cryptography, which somehow means that everything here is related to cryptography or encryption. Moreover, the encryptor function accepts an argument and encrypts it using the hard coded key and IV values. And lastly, it encodes the encrypted bytes into base 64 using the convert to base 64 string function. In summary, the function encrypts a plain text string using an AES cipher together with the key and IV values and returns the encoded base 64 value of the encrypted version of the string. So decryptor is the opposite of the encryptor function, which expects a base 64 string, decodes it, and proceeds to the decryption to retrieve the plain text string. Implant. The last function is the implant function. It accepts a URL string as its argument, initializes an HTTP request to the URL argument, and decodes it with base 64. It also retrieves the app data path and attempts to write the contents of the base 64 decoded data into a file. Lastly, if the imported file was written successfully, it returns its location. If not, it returns an empty string. In the context of malware functions, the implant function is a dropper function. This means it downloads and stores other malware inside the compromised machine. Okay, so building the pipeline. Now that we have analyzed the other functions in the malware sample, we will return to the main function to complete the malware's execution pipeline. So let's go back to main. Uh, the source code is a bit overwhelming since its code block contains over 60 lines. To make things simple, let's try to split the analysis into three. Okay, so code before the for loop. So we have a host name, we have a string, a URL, data, a string 2, account, and a flag. Okay. Retrieves the victim machine's host name, initialization of HTTP URL together with the data to submit to the reg endpoint, execution of the HTTP post request to the target URL together with the post data that contains the host name of the victim machine. It is also notable that the response from the HTTP request is being stored in another variable, and the initialization of other variables, which will be used in the following code lines. Okay, as you can see, most of the lines in the sections are all about initializing values in a variable. However, there are two notable functions calls made. The call to the DNS get host name function that retrieves the victim machine's host name. The attempt to distinguish the compromised machines based on their host names is typical malware behavior. We have already discussed the posted function, and we know that it makes a post request to the URL first argument and submits the host name as its post data second argument. In the initial step, it seems that the malware reports the host name of the compromised machine first to establish the C2 connection before executing the other functionalities. Okay, so we are almost done. Code inside the for loop before the code block of the if statement. In this section, so this is if statement. So starting here. In this section, you'll see that the for loop is written without any initialized values on the initialization, condition, and increment sections. This means the loop will run indefinitely until a break statement is used. Afterwards, the first line inside the loop uses the sleeper function wherein the count variable is being passed. Remember that this variable was already initialized before the for loop. Yep, so here's the count right here. Oh, geez. Let me go back. Count is here. Okay. The following code lines are variable initialization, wherein the string and string2 variables are used. If the value of string is http evil.com and the value of string 2 is test, the resulting value for the URL2 variable is evil.com /tasks /test. Eventually, the URL2 variable is used by the getIt function to do a get request to the past URL, and the result is stored in the it variable. So get it here, and then it's stored in the it variable. Okay. In summary, this section is focused on the preparation of variables to execute the HTTP GET request to the tasks endpoint and enters the if statement code block once the condition is satisfied. Code executed within the first if, so that's this here. Continuing the execution flow, this code block will only be reached if the GET request on the task endpoint contains a value. So yes, the section before the if it's not sleep statement is focused on initializing the variable a and text. It starts by decrypting the string in the it variable and splits it with a space character. So that's here, decryptor and then splitting by space. The a variable's value is the first element of the resulting array, and the text variable combines all elements in the same array, excluding the first element. The example below shows how the it variable is being processed. So here, shell net local group administrators. So shell net local group administrators will be its own value. Okay. Then it's the array. So the first is shell, the second is net, the third is local group, the fourth is administrator. And it starts at 0. So array starts at 0. Combining the remaining elements, excluding the first, using a space. So it's going to remove this. So then it's going to be net local group administrators. To simplify the code, the code snippet discussed above focuses on setting up the values of the a and text variables, which will be used in the succeeding conditional statements. Okay, so then the nested ifs. So that's here. The next section focuses on the condition statements based on the a variable's value. You might see that the condition in the if statements are all set to not. This means that if the condition is satisfied, meaning the variable a is not equal to sleep, it will go in the code block inside the code block to assess with another condition. For example, check to see if variable a is not equal to shell. Otherwise, it will jump to its counterpart else statement. We could simplify this code with a pseudocode like this: else if, else if, else if, else if, else if. So first it will see if it's sleep. If it's not sleep, then it will see if it's shell. If it's not shell, implant, then quit. You can follow the if else pairing by clicking the if in the if statement line. Okay. Then the contents of each conditional statement can be summarized in the table below. Sleep sets the value of the count variable which is being used by the sleeper function. Shell uses the execute command function to run OS commands with the text variable. Encrypts the command execution output using the encryptor function. Reports the encrypted string to the C2 server using the posted function via results input. So here it's shell. Okay. It spawns a shell. Okay. Should have thought of that, but I didn't. Okay. Implant executes the implant function with the redacted domain, encrypts the output of the implant function via the encryptor function, reports the encryptor string to the C2 server using the posted function via results endpoint, and then quits, set the flag variable to true. Remember that the a variable's value is based on the response received after making an HTTP request to the task's endpoint. This means every condition in this code block is based on the instructions pulled from that endpoint. Hence, it can be said that the task's URL is the endpoint used by the malware to pull C2 commands issued by the attacker. Moreover, all the implant and shell command responses are submitted as post requests to the URL3 variable. Remember, this variable handles the results endpoint. All command execution and implant outputs are reported to the C2 using the results endpoint. This may be a bit overwhelming, so let's summarize the key learnings regarding this code block. The A variable, which is dependent on the GET request made to the task's endpoint, contains the actual instruction pulled from the C2 server. This seems to be the command and control functionality, wherein the malware's succeeding actions depend on the commands the attacker resets within the C2 server. The shell and implant command responses are submitted as a post request to the results endpoint. This seems to be the malware's reporting functionality, wherein it sends the results of its actions back to the C2 server. The instructions pulled from the C2 server are limited to the following: sleep, shell, implant, quit. Breaking the loop. Lastly, the final conditional statement at the end checks if the flag variable is set to true. If that statement is satisfied, it will execute a break statement. This means that the if statement that contains the quit condition makes the indefinite for loop stop, terminating the malware execution flow. Okay. So going very quickly, how did I get these answers? So if I go to get it, here, the user agent is right here. This is the user agent. So that's what I copied. Okay. What is the HTTP method used to submit the command execution? So we have get it and we have post it. So we see here we're creating a URL. We have a post. So it's post. So what is the key used by the malware to encrypt or decrypt the data? So if we go to encryptor, we see you can't hack this super secure C2 key. So this is the key. Okay. So then go into program, main. What is the first HTTP URL used by the malware? HTTP McGreedy secret c2.thm /reg, because here it's the string and then we're concatenating this reg. So this is it. How many seconds is the hard-coded value used by the sleeper function? So we see our count is 15,000. The sleeper is in milliseconds, so that's 1,000. So if we do 15,000 divided by 1,000, it's 15 seconds. What is the C2 command the attacker used to execute the commands? Shell. So this is sleep, this is implant, this is quit. So out of these four, process of elimination is shell. What is the domain used by the malware to download another binary? So we see here stash.mcgreedy.thm. Okay. Check out the malware analysis module and the SOC level 2 path if you enjoyed analyzing malware. So that's it for this video. I had a lot of fun. I will admit I'm really not analyzing malware, but I might check out that malware analysis room. I pretty much stay in the web app space. Web is life. But this was interesting. I really don't have a lot of experience with .NET. I'm mainly like a Java person, but this was cool. And I definitely see myself looking at malware analysis later, something to learn and get my feet wet. So that's the thing with cyber. You're always learning. So I hope you learned something in this video, and I can't wait to see you in the next one. Have a good day. Bye.